Okay, let's give you guys some more practice. So here you're trying to send a square base parcel through the post office. So this here must be a square. Okay, it must be a square. You're trying to send this square base parcel through the post office, but the condition placed by the post office is that the length here plus the girth. The girth is this length here. The girth is this length plus this length plus this length and plus this length. Okay, so the condition placed on by the post office is that the length plus the girth must be less than or equal to 400. So the question is, what must x and l be in order to maximize the volume? Okay, so maximize the volume here. Work out x and l. Okay, so press pause and have a go. Okay, so to do this here, the volume is given by this, and this here is the condition placed on by the post office. Up here, the condition was less than. The condition was that less than or equal to 400. Instead of sending a small parcel, let's maximize this. So the biggest thing that we can send, let's say it equals 400. So the condition here is less than or equal to, but we want to send the biggest volume. So let's set this to equal 400. So send the biggest that we're allowed equal to. So make this equal to 400. Okay. So hang on. So the volume here is given by this, and well, this is the one that we're trying to maximize. We're trying to maximize the volume. We are going to vary x here, and this is our constraint here. Okay, so rearrange the constraint here. Make L the subject. So L equals 400. Take away 4x, and then put this into here. Okay, so that would be x squared here will be this, and this here will be our L here. And now now the volume here is all in terms of x here. So we can now draw a graph of v versus x. Okay, well anyway, from here, tidy up. It will take you to here, and then quickly sketch this quickly sketch this graph here. So we've got a graph of v versus x. So when x is big, it wants to do this. When x is small, it wants to do this. So when x is big, it wants to do a negative cubic. So it will want to do something like this, a negative cubic. But when x is small, it wants this term here dominates. So it wants to do a positive quadratic. So it wants to do something like this. When it's big, it wants to do this. So maybe something a negative cubic here. So now you can only guess. So now guess it to be something like this, and then maybe something like this. Okay. So this graph here will look something like this. But we can't really have. If you look at our parcel, x can never be negative. You can't have a negative square base. So let's forget about this region here, and we don't know where the 400 mark is, but let's just find there only seems to be one turning point here. So let's try and locate this turning point. Okay, we don't know where 400 is, and I don't think we really care about 400. We only care about when this will be at its highest. We only care when v here, where the gradient of v is 0. Okay, so from v here, let's differentiate it. So hang on. So from v here, differentiate it, it will then give you this. Okay, and then notice that x is in common, factor out the x. Notice that you can divide this by 2. That will then take you to here. But then you realize that 406, you can still factor out the 2. So take the 2 out. That will then give you this, and then merge the 2 together here. That will give you, well, basically from here you can factorize it to this. Okay, so dv by dx equals this thing here. Okay, so now we want to find out where the gradient is 0. So set this dv by dx to be 0. So set it to 0, So this thing here becomes this. So the question is, when does this thing here equal 0? Well, you can make this 0 or you can make this 0. So one solution would be x equals 0. So that means our square base where x is 0. That's quite meaningless. So we're going to forget when x equals 0. Concentrate on making this 0. So when does this equal 0? It equals 0 when x equals 200 over 3. So let's look at our graph here. So this is our graph. The gradient. So what we've worked out here is that the gradient will be 0 when x equals this. So the gradient is 0 here. The gradient is 0 when x equals this. So this bit here is 200 over 3. So we want our square base here to be 200 over 3 across, 200 over 3 high, and then now we just got to work out the length. Okay, the length here, we now got to work out the length. So earlier we had this. Earlier we had the volume equals this, and this was placed upon us by the post office. So now that we know x, we should. So this is a number. Now that we know x, this is a number, so we can work out L. Okay, so blah blah blah. So we know this and we know this, so we should be able to work out L. So blah blah blah, L equals this. Okay, so there we've just found the two dimensions. X equals whatever it was earlier, and L equals this. Okay, that will give us the parcel with the biggest volume. Okay.